Alright, here's the ones on 2-3 that people had questions on. First of all, it says the interval from 2 to 5 can be written how with x? Well, x goes between 2 and 5 and not including, because it's parenthesis, the 2 and the 5. The slope is 5, and so in the point slope form, that's y minus y1 equals m times x minus x1. So that would be y minus a minus 2, which would be plus 2, equals m times x minus 3. But we could also do it in slope-intercept form. That would be y equals 5x. 5 times 3 is 15, plus what is negative 2? Minus 17. 15 minus 17 is minus 2. Or we could do it 5x minus, the denominator is 1y equals, and then put in 3 and you get 15, plus 2 is 17. So there's the other ways, but this is the one they asked for. Now, if x is smaller than x1 is smaller than x2, so x1 is on this side, x2 is this way, then the y value of x1, so the y value of an x1, which is over here, is lower than the y value of x2. Then if that happens for all x's, then the function is increasing. Find is the function increasing from minus 2 on the interval from minus 2 to 6? Well, it decreases, then it increases, then it decreases, then it increases, but overall it's decreasing. But they didn't ask overall. They just said, is it decreasing or increasing over that interval? And it definitely is in pieces of it, but not always. So no, it's not always increasing. Is there a local minimum at 5? Yes, and what is that? 0 at x equal 5. That's the local minimum. It's a low spot that water would puddle in. List the numbers at which the function has a local maximum. It has a local maximum at x equal negative. No, that's not a local maximum because it's missing on this side. So there's a local maximum here where it run off either side at minus 2. And that's a local minimum, and then there's a local maximum at 2. Maximum is 10, but at x equal 2 there's a local maximum of 10, and that's a minimum, and that is not a local maximum or minimum because we don't know what happens on the other side. Now for this one, what are the intercepts? Well, the y-intercept is 0, 3. And the x-intercepts are negative 2, 0 and 2, 0. Domain, it goes from, that's what the x values are, and they go from minus 4 to 4. I'll do it in interval notation, minus 4 including the minus 4 up to 4 including the 4. Range, the lowest place this graph has is 0 and it goes up to 3. So the range goes from 0 to 3 including 0 and 3. When is it increasing? It's increasing from, on the interval, from minus 2 to 0. And we don't know what's happening at minus 2, so I should do open interval, minus 2 to 0. And it's also increasing from 2 to 4. 2 to 4. It's decreasing from minus 4 to minus 2. Decreasing from 0 to 2. And that's the last place. And when is it constant? Never. It's always changing up and down. Is it even? Is it symmetric with the y-axis? Yes. Is it odd? If I rotate it around the is it symmetric with no? That's point symmetry. So if I rotate it 180 degrees, does it match up? Not if I rotate it around the origin, it wouldn't match up. So no. Is it neither? No, it was even. 29. What are the intercepts? Negative pi 0, 0, 0, and pi 0. These two are x-intercepts. That one is an x-intercept and a y-intercept. Domain goes from negative pi to pi. Range, lowest place is negative 1, up to highest place is 1. When is it increasing? From negative pi over 2 to pi over 2. When is it decreasing? From negative pi to negative pi over 2. Union from pi over 2 to pi. When is it constant? Never. Is it even? Is it symmetric with the y-axis? No. Is it odd? If I rotate it 180 degrees, does it match it? Yes. In fact, if I change the sign of this, does it change the sign of that? Yes. Is it neither? No, because it's odd. 39. We're supposed to algebraically show whether this is even. We can put a point in, but let's just algebraically. Even means if I put a negative x in, if I find g of negative x, which would be negative 3 times, in place of the x I'm putting negative x, and if I square negative x I get x squared, so I get negative 3x squared minus 5, which is equal to the original g of x. So if g of the opposite of x equals g of x, it is even, and they are equal, so yes, it is equal. Which means it's not going to be odd, but odd, I change the sign of the x, I should get the opposite of what I had before. Well, this is the same, not the opposite, so no. So it's not neither because it was even. And finally, 47, well, not finally, we get some more to do. 47, we're supposed to check for even, so I will find h of negative x by putting negative x in here, so I got negative, replace the x with negative x, 3, replace the x with negative x, squared minus 9. A negative x cubed is negative of x cubed, so the negative and the negative will cancel and be x cubed. And this negative of x squared is just x squared, so this is 3x squared minus 9. Is this the opposite of this? Well, this has a minus, this has a plus. Everything else is the same, so the y value changed. When the x changed from plus to minus, the y value changed from minus to plus. So that is odd. And therefore not even. So it's not neither either because it's odd. Okay. This one. Absolute max. Is there an absolute highest place? Well, there's a hole up there, so it keeps going on going to it until it gets to the hole, but we don't know what to put down for it, so no absolute max. Is there an absolute min? Yes, it has a minimum height of 1 at x equal 0. Is there a local max? Is there a place where water will have to go both ways? No, if I pour it at the top, it goes straight through. No local max. Is there a local min? Is there a place where the water would be cupped in puddle? No place where that happens. This one. Does it have an absolute max? No. Missing. Does it have an absolute min? Well, the place that the very lowest place is gone. Does it have a local max? Now that would mean if the water fell on it, it would run both ways. No, water would run right through the hole, so not a local max. Is there a place where water will puddle? Nope, it's got a hole, so there's no local min. Doesn't have any of them. 55. We're supposed to graph this on the graphing calculator. So I'm going to grab that. Turn it on and go to y equals and clear this. And go up here and put in x to the third minus 3x squared plus 5, and I have to do this. So if I go zoom 6, I get a big window, but I don't want to see all this. I only want to look at the window from -1 to 3, -1 to 3 in the x, and so now I'll graph, and this is what it looks like on -1 to 3, and it says, is there a local maximum? Yep. And if you use the second calculate the maximum, that's between, see that's -1, that's 0, that's 1, so it's between -half and half. It's between -1 and 1, so I'll say between -1 and 1, and I think it's about 0, and it says yes, the max is 5 at x equals 0. That's the local max. Is there a local min? It looks like it happens right there. And that would be, let's see, second calculate, and that would be a local min, which is number 3, and it's somewhere between 1.5 and 2.5. It's about 2, and it says yes, it is a max of 1 at x equal 2. Local min. Alright, and then I think that's all it asked for on that one. Average rate of change for this. So y2, so I put 2 in here, 4 times that's -8 plus 4 is -4, y2 minus slope basically, minus y1, so we put 0 in here, we get 0 times -2 is 0, plus 4 is 4, over x2, which is 2, minus x1, which is 0, and the average rate of change is -8 over 2, which is -4. Do it now for 1 to 3, so I put in 3 squared is 9, -18, plus 4 is -14, minus, now we put in 1. 1 squared is 1 times -2 is -2, plus 4 is +2 over 3 minus 1. So that's -16 over 2, which is -8. And now we do this one from 1 to 4, so we put 4 in, that's 16. -32 plus 8 is -28. Minus, put 1 in. When we put 1 in, we get -2. And we get 2 over 4 minus 1, which is 3. -28 minus 2 is -30, so that's -10. Those are the average rates of change. 71, the average rate of change from this. So we put in 2, 1 squared is 1, minus 2 is -1. 1x is negative 2. Negative 2 squared is 4. Minus 2 is 2 over 1 minus a minus 2. So the average rate of change is minus 3, 4, 3, or negative 1. So what's this equation of the secant line? Well, it has a slope of minus 1, so I can go write y equals minus 1x plus, and it has to go through a point. That's not the point, that's the interval. The point was, let's see, if I put in 1 for the x, the y is 1 minus 2 minus 1. So I put 1 in, I get minus 1 plus what is minus 1. So there's the equation. Or I could do minus 3 minus x minus, change in x is 3 times the y. So minus 3 times 1 is minus 3. And a minus 3 times a minus 1 is plus 3. So minus 3 plus 3 is 0. Or I could do the point slope form, which would be y minus y1, which we said was minus 1. So minus and minus 1 is plus 1, equals m, which is minus 1, times x minus the x, which was a plus 1, and that would be the point slope. Any one of those.